The cosmic matrix displacement model, or CMD model, asserts that the most efficient VS2 cluster arrangement consists of 6 VS2s around 1 VS2 at the center and 3 VS2s on each side, known as an icosahedron nucleated. The CMD model calls this VS2 cluster a QUON, Q-U-O-N. To explain the relationship between the atom and the QUON, we can take a quick hypothetical journey into a balloon filled with hydrogen gas atoms and magnify our view so that we can see the electron clouds of the hydrogen atoms zipping around each other. Magnifying our view of one hydrogen atom on in past the electron cloud 100,000 times smaller to the proton, on through the proton cloud, down to the 3-quark cluster, and on down through 1 quark cloud to the extremely small QUON structure that, according to the CMD model, generates the quark cloud. One way to create a visual image of the displacement concept for gravity is to think of the VS1 matrix as a bucket of BBs, and the VS2 as a golf ball. If you push the golf ball into the bucket of BBs, you displace BBs. Obviously, if you drill holes into the golf ball, you would displace less BBs. In other words, the less atomic mass, or VS2s, displacing the cosmic matrix, the less gravitational force is exerted against the mass by displacement. Atomic mass displaces VS1s and sets up vector lines of force in the VS1s, meaning that there are more VS1s rebounding off of each other along the vector lines than they would if rebounding randomly without atomic matter present. What follows is a very important attribute of our early universe and quark formation into protons and neutrons. The QUON clusters are rotating at very high velocities because of conservation of angular momentum. As a QUON rotates and moves through the rebounding VS1s, it generates waves. The VS1s are rebounding off of the outer VS2 spheres, generating a displacement wave. A second displacement wave is generated from each of 6 inner VS2 spheres on each side of the QUON. But the inner displacement waves are generated by VS2s rotating slower than the outer VS2s. The inner displacement waves, therefore, have a steeper angle than the displacement waves generated by the faster-moving outer VS2 spheres. The steeper angle displacement waves cross the lower angle displacement waves somewhere out in the VS1s away from the QUON cluster and generate an interference wavepoint that continuously regenerates around each QUON. This is the quark cloud. It has been determined that there are 6 different types of quarks: the up quark, the down quark, charm, strange, top and bottom quarks. I will only use the up and down quarks as examples because the CMD model shows that the other 4 quarks are short-lived, high-energy variations of the up and down quark. When the new universe had cooled sufficiently, 3 quarks were able to cluster by displacement of VS1s. In other words, there were more VS1s rebounding on the outside of the quark clusters than between them. The surrounding VS1s' rebounding energy forces the quarks together. 3 quarks, it turns out, is a very stable arrangement. Each quark in the cluster generates gravity interference waves in the VS1s as it revolves around the other 2 quarks that result in the 3 forces that hold the quarks together. They are the inward displacement force, the outward displacement force, and inertia. The inward force is generated by the 3 rotating quarks that displace the surrounding VS1s. The result is that more VS1s are rebounding on the outside of the quarks than on the inside. The displaced VS1s set up vector lines of force. There are more VS1s rebounding along the vector lines than there are rebounding randomly in their normal state before displacement. The outward force is generated by each quark in the cluster. As the quarks rotate, they generate gravity displacement waves in the surrounding VS1s. When the waves of 2 quark clouds intersect, they form interference wavepoints that move toward the other quark in the cluster. Each pair of quarks' interference wavepoints move the other quark away. This outward force holds the 3 quark clouds apart. The inward and outward forces create a very stable cluster. If you add up the weight of the up quarks, the down quarks, and the electrons that make up a 150-pound individual, it would come to around 3 pounds. What accounts for the rest of the weight? The quarks are moving around so fast that they give us weight. As Einstein pointed out in E equals mc squared, energy is equivalent to mass. About half of our mass comes from the motion of quarks, and about half from the gravity displacement waves that hold the quarks together and apart in the proton. 15 tons of force hold 2 adjacent quarks together and apart in the quark cluster. Now that we have a stable quark cluster, I can show how the electron cloud of the hydrogen atom is generated according to the CMD model. I know that the electron has always been thought of as both particle and wave. This duality has created many mathematical and theoretical dilemmas for scientists. But the CMD model for the electron may, if test data confirms, simplify the understanding of what generates an electron and how electrons do what they do so dramatically. The CMD model for the electron may shed new light on the origin of the various orbitals for the hydrogen atom energy levels, as well as a possible solution for the wave-particle duality of light. When 3 quarks revolve around each other, they form 2 displacement gravity waves. Only one down quark generates 2 waves in the surrounding VS1s because the other 2 up quarks are revolving too close to the x-axis and therefore cannot manage to impact VS1s in the surrounding matrix. As they rotate, one wave is generated by the interference wave points that create the quark cloud. The second wave is generated by the quant at the center of the quark. The first wave has a lower angle because the quark cloud has a larger diameter than the small quant at the center and is therefore rotating faster than the quant. Faster rotation equals a lower angle wave. Where the high angle overtakes the low angle wave, somewhere away from the quark cluster, they produce interference wave points that form a sphere around the quark cluster. This continuously regenerated sphere is the electron cloud of the hydrogen atom. The more energy absorbed by the quark cluster, the larger the electron cloud orbit generated by the down quark, until the 2 up quarks are forced into larger orbits around the x-axis and begin to generate their own displacement gravity waves. The CMD model asserts that the only difference between up and down quarks is their relative orbital distance from the x-axis of the quark cluster. The CMD model also provides some tantalizing potential solutions to current problems with the standard model, such as why a neutron changes into a proton when free of the nucleus, and how a neutron is formed from protons in star cores. There are a few hard-to-believe implications, such as how to build a matter disintegrator by nullifying the gravity waves generated by quark clusters, or how a black hole generates plasma jets from the poles, and lastly, a possible way to allow matter to accelerate faster than light. The first diagram shows a large mass of atomic matter displacing more VS1s than the small atomic mass. There are more VS1s rebounding along the hypothetical vector lines than VS1s rebounding randomly without atomic mass present. The larger the mass, the greater the displacement of VS1s. The closer the small mass gets to the large mass, the more VS1s are rebounding along the vector lines of force. In other words, the basis for the inverse square law. The second diagram enlarges the small atomic mass and shows the vector lines of force that originate at the center of the large atomic mass. You can see that there are less VS1s rebounding on the inside of the small mass, facing the large mass, than on the outside of the small mass. This unbalanced force moves the small mass towards the large mass at the inverse square of the distance. This is the basic concept for gravity and how it works for all quarks, atoms, planets, stars, galaxies, black holes in our universe. The cosmic matrix displacement model asserts that there are underlying determinants for magnetism that reveals the properties of the quantum vacuum. that generate pulse gravity fields in the VS1s. If we could see the body-centered or face-centered cubic lattice of iron atoms,